Okay, on compound interest here. So you're making an investment, so an investment should go up. Okay, you're expecting more money in here. £3,000 in, 8 years at 4% per annum. That means per year. And look, 4%. Well, 4 out of 100 is 0.04. Okay, so that's dead important. And it's compound interest. So quite a dense question to get your head around here. And we want to know the value of the investment. So what's in the bank account after 8 years? Well, if we increase by 4%, what happens is we start off with 100%, we add on 4%, we get 104%. 104% is 1.04. That becomes our multiplier. We need to multiply by 1.04 8 times. So we're going to be sneaky here and we're going to say, right, well, actually, I've got £3,000. I'm going to multiply by 1.04. I'm going to do that 8 times by using the power 8. Okay, and that's definitely a calculator type job. Okay, so we're going to do 3,000 multiplied by 1.04 to the power of 8. Okay, write everything down. We've got 4,105.707, etc. Now it's 2 decimal places and also it's money anyway. All right, money. So you're going to go 2 decimal places. So it's 4105.71. Okay, it's rounded up there. Question 10. Okay, so we've got the first 5 terms. Terms are, that's the first term, second term, third term, fourth term, fifth term. A sequence, well, it follows a pattern, doesn't it? And it just says write down the next 2 terms of the sequence. So basically, what are the next 2 that come after those? Well, let's think what the pattern is. There's normally a pattern here, since it's a sequence. It's basically going down by 3 every time. So let's go down a further 3. Well, we're going to go down to 2, and then we're going to go down to -1. What's the term-to-term rule? So what gets you in between the terms? Well, it's take away 3 every time. Part B. In terms of n, so we've got some algebra, an expression, there's no equal sign, the nth term of the sequence. Now, the way I do this is, the difference becomes the number in front of n. So we're going to have -3n. Now let's go back here. We can find what's called the 0 term if we go in the opposite direction. So let's add on 3 and find what's called our 0 term. Well, that must have been 20. So actually that becomes the plus there. Okay. Let's look at the 50th term. Well, actually this is brilliant because if we replace n with 50, we'll find the 50th term. So to get the 50th term, we do a -3 times 50, and then we add 20 to that answer. So it's a -150, and then you add on 20, which gives us 130. Negative 130. Okay, next to it, part D, is the number -70 in the sequence? Well, I think the easiest way to do this is write down the nth term, put it equal to the number you're trying to work out. And if n's a whole number, yes, it is in the sequence, if it's a positive whole number. So let's solve this. Let's take 20 from both sides. And then let's divide by -3. And we get 30. So what's happened there is, it's the 30th term is -70. So yes, -70 is in the sequence. It's the 30th term. Question 11. Okay, so question 11 here. We've got a distance time, so we've got time there, distance here from home. So if you start going away from home, distance increases, coming back, it'll decrease. It's a good idea to put a bit of a scale on here. Look, it's going up by, each one of these is half an hour. So you set off home at 12, had a flat tyre at 4, at 1400, which is 2 p.m, and stopped for a rest. Okay, so, and she stopped for a rest. What time did she stop for a rest? Well, that must have been here. That must have been the rest. So it must have been at 1300 hours, 1 p.m. What speed did she travel after her rest? So here, this is a tricky bit. Speed is distance divided by time. Well, look, we've travelled from, let's put a bit of scale in here. That's 15. That must be 25. We've travelled, after the rest, we've travelled, this part here is 10 kilometres. All right. But that time here was only half an hour. Don't put 30 minutes. It's 0.5 of an hour. That gives you 20. So it must be 20 kilometers per hour. Okay, 15 minutes to repair a flat tire. Impressive. So look, that's going to be no distance traveled. Well, if that is 1430, we're going to need 15 minutes is just a little bit halfway along there. So that's repairing the tire. Cycling home at 25 kilometers per hour. Well, look, 25 kilometers away from home, it's going to take 1 hour to get home. So look, let's count on an hour from here. It's going to be 3:15 or 15:15 here. All right, 15:15. So you need a straight line that runs between those 2 points there. Okay, and then you've completed your graph. Okay, question 12. This is where, at this stage, I would say it's worth learning the table function. So it's slightly different on yours, but you can put table function in. I think it's option 2 or 3 on your calculator. Put in the function, so it's x squared minus 2. It's not the same on yours. Ignore that one. We're going to start at minus 3. We're going to end at 3. And we're going to go up in ones. And it's done it for me, look. It's given me 7, 2, minus 1, minus 2. So look, we've got 2 there. Minus 1, minus 2. We'll go down a bit. Minus 1 again. 2, and then 7. So there's a bit of a pattern there. A bit of symmetry going on. You can almost say there's a bit of a symmetrical line there. So let's plot this out and see what we get. Now, because it's an x squared, you'd expect to see a U-shaped graph anyway. We want a U-shaped graph, smooth curve. So let's plot all this down then. It's got minus 3, 7, minus 3, 7, so it's going to be there. Minus 2, 2, minus 2, 2, minus 1, 1, or minus 1, minus 1, so it's there. 0, minus 2, 1, minus 1, 2, 2, 3, 7. So it's got this nice symmetry to it. It's a curve, okay? Don't join it with a ruler, it's a nice curve. Turn it upside down. Your hand moves better this way, okay? And then you just join it all up with a nice smooth line like this. Try and go through those points. Okay, nice U-shaped curve. Okay, and last question, simultaneous equations. So first up, we've not got anything that matches up. We're going to turn this one into a 2y here so it matches. 6x plus 2y equals 48. I've just multiplied through that every term by 2. We call that equation 1, equation 2, and this is going to be equation 3. If I want to eliminate 2y, I need to add them. So I'm going to do equation 1, add equation 3. If I add those two things together, I get 4x plus 6x, which is obviously going to be 10x. Negative 2y plus 2y is 0y. You don't even write that in normally. And then you add those two together, you're going to get 22 plus 48, which is 70. So if 10x is 70, x must be worth 7. All right. Then we're going to take this answer and we're going to substitute that into one of these. Okay. So if we substituted it into, say, equation 1, we know that 4x, or 4 times 7, take away 2y, is 22. Well, that is 28 minus 2y is 22. Minus 2y must be subtract 28 from both sides. All right, that's going to give you minus 6. So y must be a negative 6 divided by negative 2. Oh, run out of space. Which gives us a positive 3. So there are two answers. Now, we're going to do a check before we put that in. All right, let's do a check. So let's take equation 2 and put our values of x and y in. So we've got 3 times x, 3 times 7. We're going to add on y, which is 3. And is that equal to 24? Well, 3 times 7 is 21, plus 3 is 24. So is 24 equal to 24? Well, yes, it is. Sorted. Okay, so I can be confident now. That's 7, that's 3. Done. Jobs good one. J good. That is not mathematical. Don't write that on your exam paper.